Hi everyone. So welcome back to EV channel. So let's try to now we are going to demonstrate how a PMSM motor is used in an electric vehicle application in the regenerative braking mode of operation. So initially I told from the positive we have to connect to the line, and from field winding from the 3-point starter we have to connect to the starting of the field winding, and output of the field rheostat we have to connect to the field winding, and from 3-point starter you have to connect to the armature rheostat, and output of the armature rheostat we are going to connect to the armature winding. And you can see here how to excite the rotor. So here we have the rotor of an, so this is nothing but the rotor of an alternator. To this rotor we are going to give the excitation with a DC supply. So we are using this rheostat as an potential divider, and output of this potential divider we are connected to an ammeter, and output of the ammeter we have been connected to the field winding. Now I will try to explain the connections. See here, so as per the circuit diagram, so from positive we had connected to the line, and from the field winding, so you can see here how to start an DC motor. We will check it in the next experiment. So here field winding we are connected to the input of the field rheostat, output of the field rheostat we have been connected to the field winding, and we have been closed. You can see here the field winding, the current is very low, only 0.9 amperes. That's why I have been used an thin wire. But when you come to the armature connection, so here from the starter armature we are connected to the input of the rheostat, and output of the rheostat we have been connected to the armature winding, and the next armature winding we are connected to the negative. So this is a completely set how to use this DC shunt motor as an prime mover for our experiment of PMSM experiment. Okay, so in order to demonstrate this regenerative braking, we are selecting this alternator, but this alternator is having an electromagnet. So in order to energize this electromagnet, we are having an DC supply. So coming to this, how to excite the field winding is, so from positive we had connected to the one end of the potential divider, and negative end we have been connected. You see here the positive end. So this is nothing but the positive end. From positive end we have been connected to the one end of the rheostat, and from negative end, so this is the negative end. From this negative end we are connected to the another end of the potential divider, and this is the output of the potential divider. From here we have been connected to the ammeter, where this is nothing but the field current. So output we have been connected to the ammeter. So output of the ammeter, once again we are connecting to the field winding X, and output of the field winding we are connected to the neutral. So this setup, so remove this bulb. So this complete setup, okay, so this complete setup will act like an electromagnet to excite the rotor of the alternator. So now the EMF is generated from the alternator as R, Y, B and neutral. So in order to measure the phase voltage, this is phase and this neutral, I have been connected a load of some 60 watts. In order to measure the line to line voltage, I have been connected a R and Y, where this voltage is nothing but line to line voltage. Now let us try to demonstrate how a PMSM motors are used in electric vehicle application, and how they act like an generator while they are deaccelerating. Sir, what is this deaccelerating is? So actually in an electric vehicle what happens is, this prime mover is not there. Okay, so this prime mover is nothing but your wheel, electric vehicle wheel. So this is nothing but the wheel of your electric vehicle. So as soon as you accelerate with 80 or 100, so the wheel will be continuously rotating like this. Okay, as soon as you remove the acceleration, the wheel still continue to rotate, and as soon as the wheel still continue to rotate, but here we are using an electromagnet. To this we have an field winding which is nothing but an electromagnet. Now we are replacing this electromagnet with an permanent magnet in such a way that, so this will act like an permanent magnet synchronous motor, PMSM motors. These are very popular motors in electric vehicle domain. So you can see here this winding which is rotating, this rotor part is made up of field winding, and stator part is made up of armature winding. Now we are replacing this field winding with an permanent magnet. So this alternator will act like an PMSM motor in permanent magnet synchronous motor. And now let's try to do the experiment. So hope we'll continue in the next video.